The next type of questions asked from the topic real numbers are the questions related to the HCF and LCM of the numbers. You have to find it, or and you have to also verify the relation between the HCF, LCM and the two numbers. Now this type of questions are depending upon the fundamental theorem of arithmetic. So the fundamental theorem of arithmetic tells us that every composite number, now a composite number is a number other than prime number, so every composite number you can express it as a product of primes, which means you can express any composite number as a product of prime numbers, and this representation is unique. It means there could not be any other representation, only the order might change. Okay, so by making use of that theorem, actually we are going to find the HCF and LCM of any two numbers, and then we will be establishing a relation also. So the question says, find the HCF and LCM of 404 and 96, and also verify that HCF into LCM is equal to product of two given numbers. Now this was the question asked in 2018's CBSE exam. So to find the HCF and LCM, first of all we have to represent these two numbers as product of prime factors. Now everybody know how to do the prime factorization. So let us first find the prime factors of 404. So let us divide it by 2, 202, then again by 2, 101. Now as I know, or as we know, that 101 is a prime number, so it cannot be further divided. So I can write 404 as 2 into 2 into 101. Similarly, let us find the prime factorization of 96 also. Okay, so 96, dividing it with 2, you get it 48. Again it is divisible by 2, you get 24. Again by 2, 12, 2, 6, 2, 3 and 3, 1. So 96 can be written as 2 into 2 into 2 into 2 into 2, 5 times 2 into 3. Okay, so now the rule for finding the HCF of any two number is you have to take the product. So HCF is equal to product of, now product of what? The smallest power, product of the smallest power, smallest means the lowest power of what? Of the common factors present in both the numbers. Yes, common factors or common prime factors. Now as we have expressed it in terms of prime factors itself, so product of common factors in the numbers. Okay, so now in this case, if I have to find HCF of 404 and 96, let us first of all find the common factors. Now which are the common factors? 2 is present in this number, whereas 2 is present in this number also. But what about 101 and 3? It is not present in 96, whereas 3 is not present in 404. So which is the common factor present in both the numbers? That is 2. But as here they have said smallest power, so if I have to write it in exponential form, I will be writing it as 2 square into 101, whereas this could be written as 2 raised to 5 into 3. Now 2 is my common factor, but between 2 square and 2 raised to 5, which is the one having smallest power? It is 2 square. So common factor is 2 and the smallest power is square. Okay, and hence this could be written as 4. So what is the HCF of 404 and 96? It is 4. Similarly, there is a formula for LCM also. Whenever you are finding LCM of two numbers, you have to again take the product of, here you are taking the highest power. In HCF you are taking the smallest power, but here you are taking the highest power of, here the condition was they have to be common factors, and here you don't have such a condition. Here you are taking you are going to take the greatest power of each prime factor. So all prime factors has to be considered here, and that too the ones with the greatest one. So LCM of 404 and 96. Now all prime factors has to be considered. So the first prime factor is 2. Here it is 2 square. Here it is 2 raised to 5. Now I have to consider the highest power. So definitely I will write 2 raised to 5. Let us go in an increasing order. After 2, which is the next prime factor, 3. Here it is present one time. Here it is not present at all. So I will write it the one time whichever is present. And the third one, 101. Okay. So 101. So 2 raised to 5 is equal to 32 into 3 into 101, and the multiplication of these three terms or three numbers is 9696. Okay, so the LCM of 404 and 96 is 9696. Now in the next part of question they have also asked us to verify HCF into LCM is product of two numbers. Now let us find the LHS first. HCF into LCM. My HCF is 4 whereas my LCM is 9696. If you multiply them, the multiplication would be 38784. Whereas let us find the product of the two numbers. So the one number is 404 whereas the second one is 96, and their multiplication is also 38784. So as you can see, LHS is equal to RHS, and hence HCF into LCM is equal to product of numbers. The next question, check whether 12 raised to n can end with the digit 0 for any natural number n. Now this question was asked in 2020 CBSE exam. For solving a question of this type also, we are going to make use of the fundamental theorem of arithmetic, meaning any number, any composite number can be expressed as product of prime numbers, and this representation is unique. Okay, so let us try to first understand what is the question. The question is said is you have to check whether 12 raised to n, where n can be any natural number, can it end with a digit 0? Now, as we know that if any number is ending with 0, it is divisible by 5, isn't it? Yes. So, if I write that if 12 raised to n is ending with digit 0, definitely it is divisible by 5. Yes, all the numbers ending with 0 are divisible by 5, which means the prime factorization of 12 raised to n will have the prime number 5 in it. Yes, because 5 is a prime number. So if you write the prime factorization of 12 raised to n, definitely in the prime factorization you will be getting a number 5 in it. Yes, if it is divisible by if the digit is ending with 0. Okay, so then only you will get the prime factorization in which number 5 is also present. So let us write down the prime factorization. So 12 raised to n. How can I write 12 in terms of prime factors? It is 2 into 2 into 3 raised to n. As you can see, the prime factors of 12 are having 2 and 3 as the only prime numbers, and they are not having 5 as a prime number in its factorization, which means that 5 is not present in prime factorization of 12 raised to n. And if 5 is not present as a prime number in its factorization, then definitely 12 raised to n will not end with digit 0. Now, why can we say this very surely? Because by the fundamental theorem of arithmetic, the prime factorization is the unique one. It means 12 prime factor, 2 into 2 into 3. This is the unique one. It means there is no other prime factorization of 12 other than 2 into 2 into 3. And hence, from this prime factorization itself, I can say since 5 is not present, so definitely this number is not divisible by 5, and if it is not divisible by 5, it will not end with digit 0. Okay. Now the next question is, explain whether the number 3 into 5 into 13 into 46 plus 23 is a prime number or a composite number. Okay, so now this question was asked in 2016's CBSE exam. So as we know, any number is said to be prime when it does not have any common factor other than 1 and the number itself. And a number is said to be composite if if it is having more than 2 common factors. So if I find out whether this given number is having more than 2 factors, or if it is having any other factor common other than 1, then definitely I could be saying that the given number is a composite number. So let us write down the number. The number is 3 into 5 into 13 into 46 plus 23. Now, if I look at the number, I can see this number is divisible by 23. So I can take 23 as common. Here 3 into 5 into 13 into, here instead of 46, now I will be writing it as 2. Okay. Whereas the next number 23 as it is. Now what is the multiplication of this? The multiplication of this whole number is 23 into 390 plus 23. Okay, so now as I have told you, if the number is having any common factor, so we could call it as a composite number. So as you can see, the number 23 is present in both the terms. It means if I try to divide this whole number by 23, it will be completely divisible, meaning 23 is a common factor present in the number, and hence we can say the given number is multiple of 23, isn't it? If it is divisible by 23 means what? It is a multiple of 23, and therefore I can say that the number 3 into 5 into 13 into 46 plus 23 is not a prime number because it is having a common factor as 23. Okay, so if it is not a prime number means it is a composite number. Now, the next question asked in 2015's CBSE exam is there are three bells which toll at interval of 12 minutes, 15 minutes and 18 minutes respectively. If they start tolling together, after what time will they next toll together? So these are certain type of questions which are asked from this topic, real numbers. The questions are based on the HCF and LCM of the numbers. So in this question, as you can say, there are three bells. The first bell is tolling after every 12 minutes, the second one after every 15 minutes, and the third one after every 18 minutes. So suppose if all the three bells toll together at say 12 p.m. So after how much time will they again toll together? Okay. So by what logic can we find out that what is the duration after which the bells will toll together? Yes, for such type of questions, you will be finding the LCM of the given numbers. So if you find the LCM of 12, 15 and 18, definitely you will be getting the value or the duration after which they will toll together. Now why we are taking the LCM? Because LCM will give me the common multiple which is present in all the three numbers table. So if they have to again toll together, there should be a common number which is present in all the in the table of all the three numbers, and hence we are going for the LCM of the three numbers. So let us find the LCM of 12, 15 and 18. So now you know how to find the LCM of the three numbers. The first number, let us divide it by 2. Now whichever number is divisible by 2, let us first divide. 12 is divisible, 15 is not divisible, 18 is divisible. Now the three numbers are divisible by, again one number is divisible by 2. So 2 3s are 6, 15 is not divisible, 9 is also not divisible. Now none of the number is divisible by 2. So now I will go for the next value, that is 3. So 1, 5 and 3. So you have to go on dividing until you get 1, 1, 1 for each of the three numbers. Again by 3 I will divide because there is one number present, 3 and 5. So the LCM of 12, 15 and 18 will be multiplication of all these factors, which is 2 into 2 into 3 into 3 into 5, and if you multiply all the numbers you will be getting the value as 180. Now but what is 180? It depends upon what is the unit of this numbers. Now the unit of this numbers is minute, so definitely your LCM value will also be in minutes, which means that all the three bells will toll after 180 minutes. Okay, so all the three bells will toll after 180 minutes. So that is the answer. So the bell will ring together after 180 minutes. So as I have said, if they both, if the all the three bells have tolled first time at 12, so after 180 minutes mean after how many duration? So 180 minutes means how many hours? 60 minutes is 1 hour, so after 3 hours. So if they have tolled together at 12, the next time they will toll together will be at 3 p.m.